I made a Game Boy game based on Storm the House, one of my favourite Flash games of all time. The only issue was, I had no idea how to do it. Oh, and I only had 72 hours to get it done. Here's how it went. The Game Boy, well, the Game Boy Color, was the first handheld device I ever owned, spending hundreds of hours playing through classics like Pokemon Red, Pokemon Blue, Pokemon Yellow, Pokemon Silver. Okay, it was basically just a Pokemon machine, but the nostalgia that this system brings is like no other. And in a similar vein, Storm the House was one of my favourite Flash games from that 2000s Newgrounds era, where you have to defeat oncoming waves of enemies with increasingly powerful weapons, while hiring gunmen and engineers to help you out. This isn't the first time I've remade this game either. Early on in my game development journey, I tried to remake the game in Unreal Engine, and while it's rather lacking visually, it actually turned out alright. But enough of the history lesson, let's break down exactly how I made this game. The Game Boy has been around for 37 years at this point, and while it's rather easy to make games look retro on modern hardware, getting a game to actually run on the OG console can be rather difficult with the very limited resources available. And there's basically three approaches that I could have taken to get this game made. The first is in the form of a ROM hack, which is what about 99% of the Pokemon style fan games are. You take a pre-existing game and replace some data with your own, like new sprites, map layouts, or sounds, and essentially use that game as an engine for your own content, or simply patch a feature into the game that was previously missing. Pokemon Blue Kaizo is a great example of a ROM hack done well, which increases the game's complexity, giving trainers stronger teams, adjusts move pools, has all 151 Pokemon available, and is designed to be a more challenging, engaging experience in the Kanto region. And developing this version was obviously made a lot easier by modding the existing game as opposed to building out the entire thing from scratch, but it does limit you to a certain extent with what you can do. The complete opposite of this, which is what you'd have to do back in the day, is to program the game from scratch using either C with a framework like GBDK or straight up assembly code. One of the coolest projects I've seen is this one by NES Hacker, who created an entire D&D game in C and documented everything in this video here, so check it out if you're interested in the more technical side of the development. But I wasn't about to take on a Game Boy crash course and make a game in only 72 hours, so I needed something in between, and that's where GB Studio comes in. GB Studio is a drag and drop game maker that makes getting into Game Boy homebrew development a whole lot easier. Using a simple visual scripting system, you can easily make all sorts of games, with templates for top-down games, platformers, point-and-clicks, and side-scrollers, which is great for anyone looking to start making games. It has its downsides like anything, but through the wonders of open source software, there's a whole community making plugins and tools for even more features. But let's get into the actual game now and go over all the highs and lows of developing this concept. The game is broken down into two main sections. The first is the base defense, where soldiers and jeeps come at you in waves, trying to destroy your base, and then at the end of the day, you're taken to the store to upgrade your damage and hire new gunners to defend your base for you. One of the biggest hurdles I faced coming into this project was a bit of a weird one. I was thinking of development like I do for any of my projects, but trying to implement features in the same way just doesn't work here. One of the things I had to get used to was to basically forget local variables for a lot of features, because there's no way to read a variable from another actor, and instead everything is based around global variables with set references in the editor. This way of thinking changed my approach for basically every element, and I'll get into more detail about that later. The first thing I focused on was the enemies attacking the base. I started by designing a basic soldier, which is just a reskinned Pokemon NPC. The movement is done with a built-in block to move an actor to a specific tile, and then it checks whether or not it has arrived at the base. If they are, it sets a variable to true, saying they're now attacking. I tried for a while to come up with a solution for attacking the base, and how I wanted them to start the attack loop when they arrive, but I just couldn't get it to work nicely. That was until I came up with a different approach. Instead of having the enemies each attack the base, I simply set a loop on the base to check every few seconds if any of the enemies were attacking, by looking at the three global variables, and then take damage for each one that's true. This is a lot easier than messing around with janky loops and timing issues, and it works perfectly. I then drew up this jeep as an alternate enemy that can spawn in place of a soldier to give the game a bit more variety. In the original games, a whole bunch of enemies start to appear as you make it further into the days, starting with the basic sword guy and ending up with tanks and rocket launchers, and so that's what the jeep does here. It's got more health than the soldier and moves faster to be a bit more of a threat, but it only appears half as often. With more work on the project, I would also add a tank enemy to be a threat later down the line, but these two are good for now. The player code is very simple, as it's all based on the point and click template that GB Studio provides. You move the crosshair with the arrows, and then on hover it switches the animation on the crosshair. Each enemy has a block in their on hit code to call to take damage if A is pressed, and that's literally it. You can shoot at the oncoming enemies with ease. Now for the gunner's code and how they work, because it's a lot more complicated than the player. How I wanted this to go was to check for the closest enemy to the base, pick that one out, and take a shot at it, dealing some damage. But this was a lot more difficult than I expected, because you can't simply get a reference to an actor during runtime, and instead I needed to store the reference to all of them in the code while in the editor. I could have used a trigger and damaged the enemy as soon as they entered it, however that's rather limited and doesn't really offer the right outcome that I was looking for. The gunner's made loop caused me a lot of issues because I didn't really know what I was doing, but I set up a loop that runs a random number from 1 to 3 to be used as an index for the 3 enemies. It then checks if the enemy is valid, which means they've got health and are in range, and if so, it does damage to them based on how many gunners you have. Originally, I wanted a way for them to fire somewhat independently. I was going to split this into 3 so they fire in a burst, but it was just too much for this to handle nicely. The gunners then loop through the enemies, except I couldn't find a nice way to break out of the loop on a successful target, so the workaround that I found was to use a global variable. The gunners use one that is set to false, and then the loop goes until it is set to true, which happens when the gun fires. To iterate through the enemies in the case that the one it checks isn't valid, I simply incremented the random index at the beginning, so from 1 to 2, 2 to 3, and 3 back to 1. It can only get to this point if one of them is valid, so I knew that eventually it would break out and not get stuck in an infinite loop. I mean, it might still happen, but who knows. But this only runs through a single time. I needed a way to fire this repeatedly throughout the game, and to do that I added a timer script to the gunner actors init code that calls this script every 2 seconds. All 3 of the actors' references are set here, and the gunners are ready to defend the base. Because all of this code needs to be attached to an actor, I actually just stuck it all on this signpost here, which acts as the secret brains behind it all. Once I had everything in place, I realised the game had a pretty bad issue. The main scene was using too many tiles, which would cause weird sprite glitches and stuttering. And this was all down to how I was trying to load the soldier and jeep sprites for each unit. What I was trying to do was load the separate sprite sheets for them every time the unit respawned, so it would swap out each unit's sprite individually, and because they had the same animation states, they would work interchangeably. The issue with this is, because it's handling 3 separate units, it was actually storing these sprite sheets 3 times, which led to those glitches happening. I thought that if you say to load a sprite in the editor, it would only load 1 instance in memory and reuse it for each appearance, but that isn't the case, so I had to fix it. The first thing I had to do here was to remove the sprite loading altogether and replace it with a different approach. So I combined the 2 units into a single sprite sheet and used animation states instead to determine whether to display the jeep or the soldier. This worked perfectly, however it does add extra checks every time I want to change state, but that's not too big of an issue. And then I realised just how wasteful I was being with the sprites. Let's take a look at the movement cycle for the jeep, for example. The jeep's frame bounces up and down, but most of the sprite is actually the same. Having this as 2 sprites makes sense, and this is how modern games would achieve this. However, the engine doesn't see this the same way, and instead it sees 8 sprite tiles, which are 8 pixels wide by 16 pixels high, and you only need to include the sprite tiles that actually change. As the top half of the sprites are identical, it doesn't need these tiles at all, and they can be removed, and in the sprite editor inside GB Studio, I can simply move the top tiles down by 1 pixel and achieve the exact same result. This takes a sprite sheet that looks something like this to one like this. It's rather jumbled up in this state, but I just had to piece the tiles together to achieve this same look. It's really interesting to approach something as basic as a sprite in a completely different way, and it's part of the reason I wanted to make a Game Boy game in the first place. And this isn't even going into the insane way that some games, like Pokemon, stored and built sprites for all of the characters, the scenery, everything. It's a level of detail that's beyond impressive, and one that I wasn't about to dive into for a game like this, especially with my lacking art skills. When it came to making the shop menu, I found it really hard to find out how to actually make UI and text heavy screens. I started by drawing the store's static text on the background directly, as that saves on resources and doesn't have to be updated at all. It's always in the same place. To purchase items, I originally had buttons that, when pressed, would trigger a script to try to purchase the item they were linked to. This worked well, but I ran into an issue once I tried to add the counters for each item. In the store, I wanted it to display how many gunners you had, how much damage you deal, and how much health your base has. And to do this, I needed a way to draw numbers to the screen. Most of the text in GB Studio is done so with these dialog boxes that pop up at the bottom, and that's how a lot of Game Boy games do handle text, but instead I wanted a nicer approach. What I did instead was to draw out the numbers 0 to 9 on a sprite sheet, and then by setting each one to a different frame on the animation, I can simply update what number is displayed by matching the value to the frame counter. I then created a script that could take 2 of these counters and convert a 2-digit number to the matching frames for both 10s and 1s. You can get the 10s by dividing the value by 100 and the 1s by doing modulus 10. These work perfectly, but you guessed it, there's a problem. If I wanted to display 3 different stats with 2 digits per stat and have the buttons to purchase them, there's no actor space left to display the player's money or anything else. It's capped at 10. So I needed another way to either display the numbers or purchase the items, and with a bit of research, I found a plugin that allows you to create more detailed menu windows, and with that I combined the purchase buttons into a single UI element. In this menu, there's 3 options for the different stats, as well as a header and prices for each of them. This wouldn't be possible with standard agents and the way I was going about it, so this is perfect. I created a loop so it only leaves the menu when the purchase is 0, which is when the player presses the B button, so you can repeatedly purchase items easily. With the freed up agents, I added a money counter to the top of the screen so you can actually see how much you have, and it was all done. Finally, to be able to actually leave the shop, I added a trigger in the bottom right that when clicked will load the base defense scene for the next day. To add a bit of scaling, the enemy count increases with every passing day, as does their total health. When you get past day 5, their speed increases. The game isn't exactly a hard one, but it's pretty fun and was a great learning experience for Game Boy development. Maybe I'll make something more in-depth in the future, who knows. If you fancy playing this one, there's a link in the description for the game. It's playable in a browser, or you can download the ROM file and get it working on an emulator or even real hardware. But that's going to do for today. Hope you enjoyed this little side project. I'm going to get back to grinding work for IG before that's released, while trying not to crumble in this heat wave. Quick shout out to my Patreon members, as well as those here on YouTube. I appreciate the support. If you become a member, you'll receive a Steam key for IG when it launches, so win-win really. Don't forget to like and subscribe, all that good stuff, and I'll see you in the next one. Cheers.